Hello. Today we are going to recap what we learned last week about bonds, bond strength, and being able to predict what kind of bonds will be made when two or more atoms come together. Today we'll also be learning about ionic bonds more specifically. So just to recap, when two or more atoms come together, two atoms at one time, they're going to have an attraction for each other's electrons. So the positive center of the nucleus, the protons, are going to have an attraction for the electrons from another atom. That's called electronegativity. The other concept that we talked about was ionization energy. In other words, how much energy does it take for an electron to be taken away from an atom, making it an ion? There are different factors that represent, determine how much energy is needed in order to pull an electron away. We talked about those down in here, ionization energy. Okay? These are the factors. Distance. The further away, if this is the nucleus, and these are the principal energy levels, or the energy shells, sometimes we talk about them in terms of energy shells. The greater the distance away, the more electrons there are in the way of the valence electrons. Remember, these are called the kernel electrons, and the outside PEL, principal energy level, has the valence electrons. So, if there are a lot of electrons between the nucleus and the valence electrons, then it will be easier to pull it off. So, this is period 1, period 2, period 3, and period 4. So this is an element in period 4. So the greater the number, the more you go down in one particular group, the easier it is to pull electrons off. At the same time, as you go down a group and atoms get bigger, it becomes more and more difficult for an atom to pull an electron away from another atom, from a different atom. So, electronegativity and ionization will always go hand in hand. How much energy it takes to pull an electron off, and what the attraction is for another atom's electrons, electronegativity. Those things will always be the same. As one goes up, the other one goes up. So if ionization energy is high, electronegativity is going to be high as well, and vice versa. Okay? So the trends are, the bigger the atom, the lower the ionization energy, the easier it is to pull an electron off. The more PELs, the easier it is to pull electrons off. And the greater the number of protons, the greater the pull on the electrons. That makes ionization energy higher. So as we go across a period, we have more protons, and therefore, as more protons are there, there will be greater pull on the electrons. And since there's greater pull on the electrons, it makes it more difficult to pull electrons off. And we talked about electronegativity already with that. And then we can predict. Remember that if we find the difference in electronegativity between one atom and another, we can find out what the difference in electronegativity is. And if it's greater than or equal to 1.7, it will make an ionic bond. That means there's very, very little sharing between the two atoms. One atom almost pulls the electron right off, and sometimes we refer to it as a transfer of electrons. If it's covalent bond, the difference is going to be less than 1.7. It's going to be less than 1.7. And from the homework sheet that we did the other day. Basically, if you have a metal on the left side and a non-metal on the right, it's going to be an ionic bond. If it's a non-metal with a non-metal, it's going to be a covalent bond. Okay, so today we'll look at the main types of chemical bonds and distinguish between them. Essentially, we're going to look at ionic bonds. Now, you can pull your notes up through Google Classroom, and I just tried it. So you can hit that clip, and it will give you the video clip that I would be showing in class. So go ahead and at any one point, punch that in, click on it, and then watch that video. So ionic bonds, we say, is a transfer of one or more electrons. And we're basically talking about from a metal to a non-metal. Metals have low ionization energy. It's easy to pull them off. And they also have low electronegativity, which means they don't have much of attraction for other elements' electrons. Nonmetals is the opposite. Nonmetals have high electronegativity and they have high ionization energy. So in this case, the nonmetal is going to pull the electron off. It's not like this one is giving it, it's this one is pulling the electron off. So it results in the formation of particles called ions, and these ions are charged. They have a charge. That means the number of electrons is different than the number of protons in each of the atoms. The positive atoms are the result of a loss of electrons. If you lose something negative, think of it this way, you lose something negative, you become positive. And positive ions have a specific vocabulary word that goes with them, and it's called cations, like the animal, cations, not cations. Negative ions are the result of the gain of electrons, and negative ions are called anions, not anions, anions. An ion has different chemical properties than the parent atom because it has a different number of electrons. And if something has a different number of electrons, that's going to determine how it acts chemically. Oppositely charged ions are held together by something that's called electrostatic attraction. The negative charge of the electron is attracted to the positive charge of the proton, and vice versa. The ionic particle is electrically neutral. An ionic bond will be formed when the electronegativity difference is greater than or equal to 1.7. And I showed you how to do that in chart S. So what's going to happen here? I've got a metal and sodium, a non-metal and chlorine. Chlorine has a very high electronegativity, so it's actually going to pull that electron off of the sodium. What happens? It loses this electron, and now it has 2, 4, 6, 8 electrons in its outer shell, since this shell is now gone, and that makes it much more stable. This one has 2, 4, 6, 7 electrons right now, and in order to make it most stable, it would like another electron. Remember that octet rule, rule of 8? So now chlorine has 2, 4, 6, 8 electrons in its valence electron shell, and therefore it is most stable. So now we have 2 more stable atoms, and we have a positive and negative, and therefore, because of these differences in charge, they will have an attraction to each other. Again, that's called an electrostatic attraction. Let's see if we can do lithium and fluorine. Lithium is 7,3. It has 3 protons 4 neutrons. It has 2 electrons in the first shell and 1 in the second. That makes it in group 1 and period 2 because it has 2 PELs. If we add it to fluorine, fluorine is 19,9. Trying to get a different color here, that's not going to work. Let's see. 19,9. Okay, 19,9. That means it's got 9 protons and 10 neutrons. It's got 2 in the first and 7 in the second. Remember, we've got to have the same number of electrons as we do protons, so it's neutral. So here's fluorine. If we add these two together, fluorine has 4.0 electronegativity. Lithium, I don't know off the top of my head, but it's in the range of 1 point something. Let's see if we can quickly look it up. I hit the wrong thing. Electronegativity, here it is, of lithium. Lithium has 1.0. That's pretty low. So I was right. So the difference here is 3.0. So what's going to happen is the fluorine is going to strip this electron right off, and then it's going to become an ion. Both of these are going to become ions. So I redraw this one. That's, whoops, that's blue. That blue. 3 protons. I still have 4 neutrons. And now I only have 2 electrons in the outside shell. Fluorine is still going to have 9 protons and 10 neutrons. It's going to have 2 in the first, and it pulled off that electron. Now it has 8 electrons in its outer shell. So if we added these up, 3 positives, 2 negatives, the positives outweigh, so I've got a +1. That's why I call it lithium plus ion. And fluorine now has 9 protons, and it has 10 electrons. In this case, the electrons outweigh the protons, so we have an extra charge there. So now we have fluorine, -1 charge, lithium, +1. Here's the attraction. Positive, negative, and this is your ionic bond. Okay? There are a few exceptions. Metal hydrides. This is a combination of a metal with hydrogen. These make ionic bonds. And nonmetals with hydrogen make covalent bonds. Group 4A, which is carbon, silicon, what else do we have there? Germanium. These only make covalent bonds. Okay? So we've only got about a minute left. This is already posted, so you can follow along or write as I do it. And that's essentially an ionic bond, an attraction between an ion that is positive and an ion that is negative. See you tomorrow.